Hello everyone, welcome to Edupedia World. Today we are going to discuss chemical reactions and equations. In today's topic, we will discuss some more examples on balancing a chemical equations. So let us start with our first example. We have to write a balanced equation for the following reaction. The reaction is methane burns in oxygen. Methane burns in oxygen to form carbon dioxide and water. To form carbon dioxide and water. So this is a first example. So first we have to write a word equation for this chemical reaction. So word equation will be like this. Methane is reacting with oxygen. Methane plus oxygen to form carbon dioxide plus water. So our word equation is this. Now we know the chemical formula of methane, oxygen, carbon dioxide and water. So now we will write the chemical formula of methane. CH4, oxygen, O2, carbon dioxide, CO2, water, H2O. So these are the chemical formulas. So now we will write the chemical formulae of all the substances in the word equation. So we get CH4 plus O2. It will give CO2 plus H2O. Now we have to balance this chemical equation. First of all, we will count the number of various atoms in reactants and products. So number of various atoms, like number of carbon atoms in reactants and in products. Number of hydrogen atom and number of oxygen atoms. I am writing the chemical equation again here for counting the various number of atoms in reactants and products. CH4 plus O2, it will give CO2 plus H2O. So number of carbon atoms in reactant is 1, CH4, 1 C atom, and in product it is also 1. Number of hydrogen atom on the reactant side is 4, CH4, 4 hydrogen atoms on the reactant side. And how many hydrogen atoms are there on the product side? 2 hydrogen atom from H2O, 2 hydrogen atoms. Number of oxygen atoms on reactant side is 2 and on product side it is 3. So the number of carbon atom is equal on both sides, that is 1. But the number of hydrogen atoms and number of oxygen atoms are not equal. There are 4 hydrogen atoms on left side but only 2 hydrogen atoms on the right side. To have 4 hydrogen atoms on the right side, we will multiply H2O by 2 and will write as twice H2O. So now our equation will become CH4 plus O2, it will give CO2 plus twice H2O. Now again we will count the number of various atoms on both sides. Number of carbon atoms, number of hydrogen atoms, and number of oxygen atoms on reactant side as well as on the product side. Now how many number of carbon atoms are there on reactant side? 1. And number of carbon atoms on the product side is also 1. Number of hydrogen atoms on reactant side is 4, and number of hydrogen atoms on product side is also 4. So number of hydrogen atom is now balanced. Now let us count the number of oxygen atom on reactant side. It is 2, and number of oxygen atom on product side, it is 2 and twice O. It means 4 oxygen atoms are there. So only the number of oxygen atom is unequal now. There are 2 oxygen atoms on left side, that is on the reactant side, and 4 on the right side, that is on the product side. To have 4 oxygen atoms on the left side, we multiply O2 by 2 and will write as twice O2. So now equation will become CH4 plus twice O2, it will give CO2 plus twice H2O. Now again we will count the number of various atoms on both sides. Number of carbon atoms, number of hydrogen atoms, and number of oxygen atoms on reactant side as well as on the product side. How many number of carbon atoms are there? 1 on both sides, reactant as well as product. Number of hydrogen atoms, 4 on reactant side and 4 on the product side. Now number of oxygen atoms is also 4 on both the sides. Now our equation is a balanced chemical equation because it contains an equal number of various types of atoms in reactants and products. So this is a balanced chemical equation. Now we will make this equation more informative by indicating the physical states of the reactants and products, as well as we can also include the heat changes taking place in this reaction. So now we will make this chemical equation more informative by indicating the physical states. We know that methane is a gas, so we can write methane as CH4 gas. Oxygen is also a gas, so we will write oxygen as O2 in small brackets gas. Carbon dioxide is a gas, so we will write it like this, CO2 small letters gas. But what about the physical state of water? If a reaction is taking place in aqueous medium, then we will write H2O is in liquid state, and we will write it like this, H2O liquid. If the reaction is taking place in vapor phase, then H2O is in the gaseous state and represented as H2O gas. But in this case, methane gas burns in oxygen gas to form carbon dioxide gas and water vapor or steam. So water is in the gaseous state here, and we will write H2O in gaseous state. So if we put the physical state of all the reactants and products, then the above equation can be written like this, CH4 gaseous state plus twice O2 in gaseous state, it will give CO2 in gaseous state plus twice H2O in gaseous state. Now we will discuss the heat changes taking place in this reaction. When methane burns in oxygen to form carbon dioxide and water, a lot of heat is produced. So this is an exothermic reaction. An exothermic reaction is indicated by writing plus heat sign on product side. So the above equation can finally be written like this: CH4 in gaseous state plus twice O2 in gaseous state, it will give CO2 in gaseous state plus twice H2O in gaseous state plus heat, because this is an exothermic reaction. A lot of heat is produced in an exothermic reaction. So this equation gives the physical states of reactants and products as well as the heat changes taking place in this reaction. So this is a more informative equation. Now let us discuss our second example. Sodium metal reacts with water to give sodium hydroxide and hydrogen. So the word equation can be written like this: sodium is reacting with water to produce sodium hydroxide, plus hydrogen. Now we know the chemical formulae of all the reactants and products, so we will write the chemical formulae instead of name. So for sodium we will write like this: Na is the chemical formula of sodium. It reacts with water, that is H2O. It will give sodium hydroxide. NaOH is the chemical formula for sodium hydroxide, and hydrogen, that is H2. This equation has 2 hydrogen atoms on left side but 3 hydrogen atoms on right side. So we can write the number of atoms of all substances on reactant side as well as on the product side. Number of sodium atoms, number of hydrogen atoms, and number of oxygen atoms on reactant side and on product side. Sodium 1 on reactant side, 1 on product side, so it is balanced. How many number of hydrogen atoms on reactant side? 2, and on product side it is 3. Number of oxygen atoms on reactant side is 1, and on the product side it is also 1. So only number of hydrogen atoms is unequal. So what we will do, we will multiply H2O by 2 and NaOH also by 2. So we have an equal number of hydrogen atoms on both the sides. So what we will do, we will write Na plus twice H2O. We have multiplied H2O by 2 and we have also multiplied NaOH, that is sodium hydroxide, by 2. So twice NaOH plus H2. So again we will count the number of all the atoms on reactant side as well as on the product side. Number of sodium atoms, number of hydrogen atoms, and number of oxygen atoms on reactant side and on product side. So 2 number of sodium atoms on reactant side and 2 sodium atoms on product side. 4 hydrogen atoms on reactant side and 4 hydrogen atoms on the product side. And how many oxygen atoms we have on reactant side? It's 2, and on product side it is also 2. So this equation contains an equal number of sodium, hydrogen and oxygen atoms. So this is a balanced chemical equation. Now we can make this equation more informative by writing the physical states of all the reactants and products. Sodium is a solid and water is a liquid. So we will write the chemical equation like this: twice Na. Sodium is in solid state, so small s, and water is in liquid state, so we will write twice H2O in liquid state. And sodium hydroxide is an aqueous solution, twice NaOH, it's in aqueous form. And H2, that is hydrogen, is a gas, so we will write H2, it's in gaseous form. So this is a chemical equation, and we have made it more informative by writing the physical states of all the reactants and the products. Now let us discuss another example, a third example. In this example, we have to write a balanced chemical equation. In this reaction, hydrogen is reacting with chlorine and it is producing hydrogen chloride. Hydrogen is reacting with chlorine to produce hydrogen chloride. We can write the chemical formula of all the reactants and products. Hydrogen as H2, chlorine as Cl2, and hydrogen chloride as HCl. So our equation is like this. Now we have to balance the chemical equation. So first we will count the number of hydrogen and chlorine atoms on both sides of reactant as well as on the product. For balancing this chemical equation, we have to count the number of atoms on both sides of this reaction. Number of hydrogen atoms, number of chlorine atoms on reactant side as well as on the product side of this chemical reaction. How many number of hydrogen atoms are there on reactant side? It is 2, and on product side it is 1. Number of chlorine atoms on reactant side is 2, and number of chlorine atom on the product side is 1. So what we will do next is to have 2 hydrogen atoms and 2 chlorine atoms on the right side. We have to multiply HCl, that is hydrochloric acid, by 2. So our chemical equation will now become H2 plus Cl2, it will give twice HCl. So this is a balanced chemical equation because it contains an equal number of hydrogen atoms and chlorine atoms in reactants and in products. So now we will make this chemical equation more informative by writing the physical states of reactants and products. Here in this reaction, hydrogen, chlorine and hydrogen chloride all are gases. So we can write the above equation with state symbols like this: H2 in gaseous state plus Cl2. Cl2 is also in gaseous state. It will give twice HCl in gaseous state. So this is a balanced chemical equation, and it is also indicating the symbols, state symbols of all the reactants and the products. Now we will discuss another example. In this reaction, hydrogen gas combines with nitrogen. Hydrogen gas combines with nitrogen to form ammonia. So we can write word equation like this: hydrogen plus nitrogen it will give ammonia. Now writing the chemical formulae of all the reactants and products, we obtain H2 plus N2. It will give NH3. This is the chemical formula of ammonia. This equation has 2 hydrogen atoms on left side but 3 hydrogen atoms on right side. So we have to multiply H2 by 3 and NH3 by 2 so that each side gets 6 hydrogen atoms. So our equation will become thrice H2 plus N2. It will give twice NH3. Now this equation contains equal number of hydrogen atoms and nitrogen atoms on the both sides. So this is a balanced chemical equation. Now to make this equation more informative, we will write the state symbols of reactants and products. Thrice H2, hydrogen is in gaseous phase, plus N2, it is also in gaseous phase. It will give twice NH3. This is also in gaseous phase. So this is our balanced chemical equation, and which is also more informative because it is with state symbols of all the reactants and products. Thank you for watching Edupedia World Videos.